AP Calculus. I'm going to get through this as fast as I can. This is test 9, walkthrough. We're given the limit as x approaches 3 of f of x minus g of x, h of x, over h of x. And we're asked to find what that limit is equal given these fun facts. Well, this is basically a limit laws type problem. So this is the same as writing the limit as x approaches 3 of f of x minus the limit as x approaches 3 of g of x times the limit as x approaches 3 of h of x all over the limit as x approaches 3 of h of x. All right, now you just do some substitutions. What are we told? The limit as x approaches 3 of f of x equals L. Limit as x approaches 3 of g of x is equal to m. The limit as x approaches 3 of h of x is equal to 4. And the same thing at the bottom here, 4. All right, this is the same as L over 4 minus m4 over 4, or L over 4 minus m. And that should be your answer. And that was a choice. That was choice C. Question number 2. We're given this piecewise defined function and asked to ensure that f is continuous on all reals. Well, immediately you see that x will be continuous for this function because it's a polynomial, and x will be continuous for this function because it's a polynomial. So the only issue we have to deal with is can we make the function continuous at x equals 2, at the juncture point. How are we going to do that? Well, you need to know the limit definition for continuity to point. Limit as x approaches that independent value of f of x, that thing, the two-sided limit, has to equal f of 2, which is a dependent value at 2. So let's start with the left-hand side. Piecewise defined function, theoretically you have to break this up into the limit as x approaches 2 from the left of f of x. As you approach from the left, you're going to use ax squared. And that's going to have to equal the limit as x approaches 2 from the right. You can use this piece of b of x. Right, and then this thing right here, f of 2, well, that's just a plug and chug maneuver. So let's take this limit. Plug and chug, and what do you get? You get 4a. Take this limit right here, plug and chug, and you get 2b. And then if you plug in 2, which piece can you plug 2 into, top or bottom? Top. So that's going to be, again, 4a. So these two have to equal, for the two-sided limits to equal, and then they in turn have to equal this. So you know 4a has to equal 2b is the big idea. Okay, so which ordered pair will make 4a equal 2b? And the answer to that is only the set a equals 5/6, b equals 5/3, right, which is choice D. Problem 3 says log base 2 of x. Not taking its derivative, we're taking its integral. If I had just said, what's the antiderivative of the natural log of x? Well, you would say, oh, I know what that is. That's x ln of x minus x plus c. Very good. What does this log base 2 do? Well, you have to remember how to adjust for it. The way you adjust for it is 1 over the natural log of 2. Okay, plus c, something like that. So it's just the antiderivative of natural log of x, which by parts you'd memorize this answer, and then with the adjustment factor, the 1 over the natural log of 2. Number 4, we've got xy plus y squared is equal to x plus 1. We're asked to find dy dx when x comma y is 2 comma 1. No problem, okay? Implicitly differentiate here is the key. Use the product rule. First times the derivative of the second plus the second times the derivative of the first. That takes care of that. Now you go on to the next piece. More implicit differentiation. 2y dy dx equals derivative of x is 1, derivative of 1 is 0. So no problem. Now we isolate dy dx and you get dy dx, these two terms, x plus 2y equals 1 minus y, or dy dx equals 1 minus y over x plus 2y. That's a function, right? That's a derivative function. Well, it's actually it's a relation, a derivative relation, right? It's got 3 variables in there. But we want to go ahead and plug in this ordered pair and find the actual value. So let's plug in 2 comma 1. You get 1 minus 1 over 2 plus 2 times 1, which is going to equal 0. And that's your answer. So the answer to number 4 should be B, which is 0. All right, on to number 5. Number 5 says find the area between y equals 3 to the x-axis, which of course is y equals 0, x equals 0, and x equals 5. No problem. Best thing to do is graph it so you know what it looks like. This is a what type of function? It is an exponential growth function. So, boom, right there. Next, y equals 0 against the x-axis. It's a boundary. X equals 0, that's the y-axis. That's a boundary. We got this is y equals 3 to the x. And then x equals 5, which is probably something out here. X equals 5. So this is the region we're talking about. So how do we find the area of a region? You know how to find the area of a curve. Use first you find the area of a subrectangle. See that subrectangle right there? What would be the area of a subrectangle? Base times height. Base is dx. Height is what? 3 to the x? Okay. And then you want to sum up that height times that base, the area of the subrectangle. You want to sum up all the areas of the subrectangles from x equals 0 to x equals 5. Well, then again, you have to differentiate. If I told you what's the antiderivative of 3 to the x, if I told you what's the antiderivative of e to the x, you would say e to the x, right? So you get the idea it's probably going to be 3 to the x. However, there's got to be some sort of adjustment factor. What is the adjustment factor? It is over the natural log of 3. It's just stuff you have to memorize, right? Just the rules you have to memorize. And then you want to evaluate this from x equals 0 to x equals 5. And so you're going to get 3 to the 5th, which is 243 over the natural log of 3, minus 3 to the 0, which is 1 over the natural log of 3, which is going to equal 242 over the natural log of 3, which is your answer. And so the answer there is C. 242 over natural log of 3. Now, ask ourselves what the units are. Well, it's area that we measured, so it should be in units squared. All right. Well, that's the multiple choice, so let's call that, and I'll put up another video for the rest of them in a second.